Shreya Balaji is a senior at Harvey Mudd College, California, majoring in computer science and mathematics. With a strong passion for mathematics, she has conducted research at UCLA's Computational and Applied Mathematics program. Beyond academics, she is an accomplished Bharatanatyam dancer and a licensed private aircraft pilot, showcasing her diverse talents and dedication. Let's welcome Shreya to give her 3-minute speech.
I want to show you how AI can actually help free people who have been wrongfully convicted of crimes. So the big picture is imagine that you're looking at a jigsaw puzzle, a 1,000-piece jigsaw puzzle. There are thousands of pieces in this puzzle, thousands of different colors. There isn't really a clear pattern as to how you want to solve it. Essentially, what you're trying to do is the first time you make this jigsaw puzzle and you put it together, you don't really know what's happening, and then you take it all apart and you try to do it again. And the second time that you try to do it again, you kind of know the strategy as to what pieces you want to do first, what shapes you want to form first, and what colors you want to put together, what pieces, such as the corners and the edges, first before anything else. You kind of have an idea of how you want to build the puzzle. And over time, as you do the same puzzle over and over and over again, you're training yourself to be able to do the puzzle with more speed and more efficiency. Essentially, that is what NMF or non-negative matrix factorization is. It's it breaks down a puzzle into smaller sections, and so it reveals clusters or themes or ideas that tend to appear together. And it has a lot of it has a lot of good impacts on computer science and on machine learning and on mathematical modeling. However, it is a little bit of old school. It's a little bit of an old school way of doing this actual formulating for you. So essentially, with NMF itself, it assumes that everything in your data is very neat. It has all linear relationships, so it's all in straight lines, very, very simple relationships to understand. Now, the data that I was working with was in the legal justice system. I was studying murder case data, and I was trying to develop an AI with a team of other students at UCLA, trying to essentially be able to make an AI that can help innocence organizations that are trying to free people that were wrongfully convicted of crimes with really helping them with what they're trying to do. So, essentially, when you're looking at massive legal documents, so these legal documents have thousands of pages of transcripts, reports, testimonies, and we have so much information about about each case, about each victim over here. However, buried in all of these legal documents, buried in everything, is can be information that could actually be very powerful, could be very useful to us. So I used something called semi-supervised non-negative matrix factorization. And semi-supervised essentially helps the NMF learn from both unsolved puzzles, so the unsolved jigsaw puzzles, for example, as well as puzzles that we've already solved and things that we've already learned. So it has some learning from existing information, and it uses that existing information to help it learn new things. So we use a semi-supervised algorithm, and we combined that with a kernel algorithm of NMF. And so the kernel, essentially, you can plug in a different kind of kernel each time, and you can help transform how the AI is able to see this information. So you can change what kind of relationships it's looking for, the randomness of of that information that is getting inputted into it. And overall, you are able to now not only looking at keywords that could help free someone from being victimized for a crime that they didn't do, but you're also able to look at more subtle threads that are running through each of the cases and how they even correlate with other cases. So, for example, something that a human might miss on the 500th page of this document of a court transcript, an AI could be able to flag as part of this pattern. So, overall, in this day and age, computer science and mathematics and the intersection of the two of those with artificial intelligence is becoming much more prevalent. And oftentimes they are being used in cases where they're replacing humans, and that's not necessarily the most forward and the most useful form of using AI. However, in this project, I really learned about how AI can help us change someone's life. It can help put people out of jail when they've been wrongfully convicted of a crime. It can give a voice to someone who was silenced in a criminal justice system. And so when we're looking into the data, our human eyes, our naked human eyes, aren't able to see as much as a computer can. And that's really unfortunate. However, the computer can help us understand how we can better analyze certain documents, what patterns we might be able to learn. So by using a kernel semi-supervised algorithm where we're learning from the existing and learned information, we are also inherently able to teach ourselves what we should be looking for, the subtle patterns that we might want to look into as lawyers, as court justices, et cetera, et cetera. Thank you so much for listening to me.